So I really only have one additional thing to go through here, which is the idea of the sample size and how we do the calculations for sample size. So this is where, if you're asking the question, how big of a sample do we need to obtain if we want to calculate the interval to a certain degree of precision. All right, so I'm going to go ahead and clear my screen here on this. Okay. What we want to do is we want to determine, let me make this a little larger. Okay, so what we're talking about here is the idea. We want to look at we want to determine the desired sample size. So, we want to determine the sample size necessary to obtain a specified or desired margin of error. Okay, and what we're going to do is we're going to first focus on the idea that we have the known parameter. Now, to do this, so here's where things really start to get wonky. All right, so in our notation, we actually now end up with even more values for P. All right, more notation. So again, we knew that P star was the population proportion. Okay, now the truth is this is unknown. Okay, we just don't know what it is. P hat, on the other hand, is the sample proportion. Okay, it's the sample proportion, and it's known because we can get the sample, but it's at best, it's an estimate. So what we do is if we think we know what P star is, we have a guess for P star, and we use P with a little tilde on top. This is a guess for what P star actually is. Okay. All right, so what's the formula? So if I have this guess, if I know, that's what I mean by known. This P tilde is known. It's known in the sense that I have a guess for what it is. The formula is, I take n is the square of the critical value times my guess for the population proportion times the 1 minus that guess. And we divide this by the square of the desired margin of error. So if you tell me a desired margin of error and a confidence that you want, if you have a guess for this P tilde, I can plug that value in. Okay. So what I need, so one of the important things to note that we need, so we need to know that there's a desired confidence level. That desired confidence level C, this is going to lead us to the Z sub CV value. That confidence level gives us what the critical value is. Okay, the easiest way to get that is just using norm S inv. One minus C over 2. All right. So in other words, you have a desired margin of error. Let's say you want the margin of error to be plus or minus. So on top of this, then, so we have our desired confidence level. The next thing that we need is we need this desired margin of error. So the desired margin of error, which essentially is our desired level of precision. So I need to know the margin of error. I need to know my confidence, which gives me the critical value. And then last but not least, I need my guess for, actually, let me just draw with this circle. I need a guess for this p hat. Okay. These are the three things that I need for this calculation. Okay, these are the three things that I need in this to obtain this calculation. If I have these values, then I can plug those in to get my, if I have those values, I can plug those in to get the desired result that I'm looking for. Now, the one last piece that we have to add to this is there's something called the ceiling function. And the ceiling function says, oh, that's not what I want. So the ceiling function says you take this value and you always round it up. So it's sort of like square brackets, but there's no bottom on the square brackets. All right. So let me go ahead and do a calculation for this. And let me go ahead and save this and let's do a calculation. All right, let me save. I kind of have to clear everything and start over here. So let me go ahead and clear it all. Okay, so we're doing an example here. We're plugging everything in. Okay. All right, so let's say here's the information that we have. We're working with the following. We want confidence of 95%. We want a margin of error of plus or minus 3%. And we believe that the population proportion is about 15%. Okay. All right, so the formula would be something like this. So N equals, so we have the critical value squared times p hat, well, sorry, p tilde times 1 minus p tilde. And this then is all divided by the desired margin of error squared. And then last but not least, we always remember that once we get that value, we actually round up to the nearest whole number. All right, so punching these values in. So we already know that, I already know the value for z sub, because we've calculated this one already, it's 1.96. So I'm going to take that value. We have our guess for p tilde. So it's always best to write these as decimals. So I'm going to write this as 0.15 times 1 minus 0.15 or 0.85. And then we're going to divide by the desired standard of error, which is 0.03. Again, always best to write all the percentages as decimals. We'll square that. And then once we have that, we will round up to the nearest whole number. And when I do this, I get, so if I punch all these into the calculator, I should get a value of about 544 and change. And if we round that up to the nearest whole number, that would be 545. So the final result is that we would need a sample of about 545 people. So that's the desired sample. We need about 545 people to get a margin of error of 3% if the population proportion is actually about 15%. So I cannot stress this enough. I cannot stress this enough. This is one of the things that shows up all the time in these sorts of problems. You always, always, always round up. Okay, so you always, always, always round up. Now, how does this formula change? So what we're going to do is we're going to do a little bit of parallel collective processing here in a second. But what we need to talk about is we also need to talk about the formula. So if we don't have a guess for p hat, for p tilde, right? If we actually don't have a guess for p tilde, what we do, so let me go ahead and get rid of this. So if we don't have a reasonable guess for p tilde, so if I don't have a guess for this, I'm going to actually, turns out that I can actually, if this is unknown, meaning we look at it and we say, look, I don't know if it's 5%, I don't know if it's 85%, I really just don't know, then essentially what we do is we always default to a p tilde of 50% or a half, which means this formula, if I plug in half here, 1 minus a half is a half. So that means this formula actually changes. So you can either remember that you're just plugging in 50% up here, or if the estimate is truly unknown, that's the same thing as saying n equals, if this is a half times a half, that's half squared. So I can rewrite this as z sub cv divided by 2 times the desired margin of error, that's an m, not a mu, squared, rounded up. So this is an alternate formula. So either you remember that, so you either remember that you're replacing, if you don't know an estimate, you use 50%, or either you plug in 50%, or you do the sorry, you either plug in a p tilde of 50%, or you can use this this version of the formula. They're the same thing, but it might be easier to remember one versus another, one way versus another. All right. So the last thing I wanted to do was just sort of show a couple of little variations on things. And we have time to do this, and I'm going to actually ask you all to sort of help me build this. So what I'd like to do is I'd like to work together to sort of fill in this table. All right. So I'm going to take what we started with, the 95%, 3%, and 15. Okay, so I'm going to take these numbers. So let me go ahead and clear the screen here. We're going to do a bit of parallel processing. We're going to build a table here. So for the different sample sizes, here's the table that we're going to build out. And I'll start with what we just had. Desired confidence level. We have a desired margin of error. And we have a guess for what p hat is. And what we're looking for then is, what is that desired value of n that we actually wanted? All right, so if I plug in the values we were just working with, okay, so the values we just plugged in were, we just plugged in 95% for the desired level of confidence. We plugged in a margin of error of plus or minus 3%. We believed our guess for p tilde was 15%, and that gave us a result of 545. That was the necessary sample size we needed. All right, so I'm going to ask, the first group is going to do the following. The first group is going to do the same calculation, but I'd like you to change the confidence level to 98%, but everything else remains the same. So it's still 3% and margin of error of 3% and a margin of error of 15%. The next group will do, they'll keep the margin of, keep the confidence level of 95%, and the guess of 15%, but they're going to change the desired confidence. We'll have a much more narrow desired confidence level of 1%, margin of error. And then the last group is going to change the estimate from 15% to 40%, and we'll keep the other values the same as we started with, which was 95% and 3%. So this will kind of give us an idea of how these things all change. So I'm going to add, one more calculation to this, and that's where we have 95%. We keep that the same. We have 95%. We have 3%. But we don't know, we don't actually have an estimate for P tilde at all, which means we essentially use 50%. Okay, I will go ahead and tell you that if we did that, then we would need a value of 1,068 to actually get that value. So 770. So what we can see is that as all of these changed, as our confidence went up, we needed a larger sample size. I'd like you to think on whether that makes sense. As the margin of error got narrower, we needed a larger sample size. Okay, and then last but not least, in this case, when we had so if our precision got closer to 50%, the sample size was required to go larger as well. And now for the last group that came in, I added a row here, which is the row that is sort of that last formula I showed, where if we had confidence and a desired margin of error, but we had no estimate for P hat, i.e. using 50%, then the best value we would have would be 1060. All right, so let me give you the final end of class question. The final end of class question is, I'll write it in here in red on top. So let me actually do it in orange on top. So if we had 95% confidence, a desired margin of error of 3%, and an estimate of 60%, okay, what's the necessary sample size we need? Now, I'm going to tell you that as an end of class question goes, you don't have to do any work because there is something in this table that actually tells you what that answer is. Okay. All right. I'm not going to say too much more than that, but this is the last end of class question. I think it's number 3 for the day. Okay, so this is the end of class question. What is this necessary sample size? You're welcome to work it out by hand, but there's a piece of information that you can borrow from this table that allows you to jump to what that answer would be straight away. All right.